Okay, so I'm going to basically take the quiz right now for the first time. I have no clue what the answers are, but I'm going to I'm going to make the answer key right now and help you guys kind of see my thought process behind some of these problems. Okay, so first one asks us for the measure of angle ABC. Okay, so the first thing that I always do in my head usually, but I mean on this it's kind of nice I can actually draw it and erase it. So first I need to know which angle I'm looking at or looking for. Okay, so ABC means that angle right there. Okay, so what I know is that from this chapter, the main theorem we've used says that if we use the same endpoints and connect and make a central angle, then that central angle should be twice that angle. Okay, so again, we know that this red angle is 25 because they tell us, so that means the purple one has to be 50. Okay, so this first one, measure of angle ABC, 50 degrees. Okay, the next one, they're asking us for the measure of angle DBC. Okay, so DBC is that one in there. Okay, so I'm going to try the same thing. If I take those two endpoints and connect them to the outside of a circle, I know the red has to be twice the purple, but I don't know the purple. Okay, so I could connect them to this side of the circle, and I know that the red is going to be twice the purple, but again, I don't know the purple. So that means I have to use something else. So the next thing in my mind, I'm thinking that if I were to go all the way around, like halfway around this circle, either that way or that way, I guess, or what you want to think about it, it's going to be 180 degrees. Okay, so if I could figure out this one and this one, then I could add those two black ones up, subtract it from 180 to get the red one. And you can see out here, we already have that one is given to us as 80. Okay, so I know that this one's 80. Okay, this one here, to try to figure that one out now. Okay, so we're looking for this angle. So if I take those endpoints, going back to that same theorem, and connect them here, if this one's 25, that means the black one that we were just looking for has to be 50. So now we have 80, we have 50. What's left to get to 180? Another 50. So that means this one that we were just looking for here, DBC, is also 50. Kind of for some different reasoning. I mean, same reasoning, but we had to use a lot more of it. Okay? Next one is asking for measure of angle ACE. Okay, so that's ACE. Okay, so again, I'm going to try that same theorem that we've been using. That's like my go-to every time. Take the endpoints. Instead of connecting them to C, see if we connect them to the middle, and if we know what that angle is. Because if we do, then this red angle has to be twice the black angle. Now the red angle, we don't have it, but it's half of a circle, which is 180. Half of 180 is 90. So that means the measure of the angle we were looking for, ACE, is going to be 90. Alright. Now, they're asking us about DAE. So now we're looking at DAE. Okay, so again, we have an angle that's on the outside of a circle. So if I can use those two endpoints, connect them to the inside of the circle, then that red angle has to be twice the black angle. Okay, the black angle is what we're looking for. The red angle, we know is 80. It's given to us. Half of 80 is 40. So DAE is going to be 40. Alright, when we get to ADE now, that's going to kind of actually, this is going to be the same as number 3. So ADE is that angle. So we want to try to use those endpoints and connect them to the middle. That's 180. So that means ADE has to be 90. So 3 and 5 are almost like basically the exact same reasoning. One of them is just that one, and the other one is this 90. Notice those same endpoints, just connected to a different part of the circle, but they're still both 90 because they're half of the red. Okay, number 6 now. 6 is asking for FCB. Okay, so this is where we're going to have to use the tangent stuff. Okay, so we're given here that FC is tangent to the circle. Okay, tangent, mathematically, in Mathlish, means that it intersects the circle at exactly one point. Okay, in this case, the one point is C. We call that the point of tangency. Okay. In English, it just means, tangent line means that it gets right up next to the circle, barely touches the outside, but doesn't actually go through it. Okay, so it's only going to cross at one point. There's another theorem that came up in this chapter that we didn't really talk about yet, but we're going to talk about it right now. It says that if there is a line that touches a circle at exactly one point, like this, and you connect that one point to the middle of the circle, like that, then it has to cross at 90-degree angles. That's what the theorem says. Okay? Again, we have a line, touches a circle at exactly one point. If you take that one point and connect it to the middle, it's always going to be 90-degree angles. You might remember some stuff about doing perpendicular bisectors in Math 1. Kind of goes back to that. Alright, and then 7, last one here. 7's asking for CED. So that's this angle there. Okay, so now we have an angle on the outside of a circle. So we got to go backwards, use those endpoints, connect them to the middle to make a central angle. And if you remember, this is angle DBC. We knew that one was 50 from number 2. So that means the black angle that we're looking for over here, that one would have to be half of 50. So 25. Alright? And so that's 1 through 7. Alright, now when we get to 8, first thing they do is ask us for the measure of angle ANM. Okay, so we're looking for this angle. So if you think about this regular pentagon, it's going to be split up into 5 congruent triangles. Okay, so if we can find one of those interior angles, all we have to do is cut it in half, and we find ANN. Okay, so remember, if you have 5 equal triangles, you're going to have 5 equal angles all in the middle. Those all have to be the same. So to figure out what each one of them is, we just take the full circle divided by how many angles there are, and we should get 72 degrees. So what that means is that the measure of one of those angles is 72. Now if we're looking for just half of that, then that should be 36. Okay, so the measure of angle ANM should be 36 degrees. Alright. Next thing they do is they ask us for the length of segment AM. Okay, so Now what we want to do to figure out this side, remember we have that angle is 36. This side we're looking for, we know this side is 8. So we need to set up a trig ratio, or a trig equation, using those three numbers. Okay, so standing on 36, notice we're looking for the opposite. We have the hypotenuse. Opposite and hypotenuse is sine. So we're going to do sine of 36 equals x over 8. And then now, whenever we write an equation with an x in it, especially, all we have to do is solve that, and that'll give us what we're looking for. So to get rid of the 8 on the bottom, multiply both sides by 8. And so x should be equal to whatever 8 times the sine of 36 is, which should be 4.7, about. Okay, so what that means is that the length of segment AM is 4.7 centimeters. Okay, now the last one, they want us to find the perimeter of the pentagon. So if we can just figure out the length of one of these sides, we just multiply it by 5 and we're done. Remember, we knew that AM is 4.7, so half the distance is 4.7. So that means the full distance is going to be 9.4 if we just multiply that by 2. Alright, and then again we got 5 sides, so we do 9.4 times 5, and it should come out to 47 centimeters. And that should be 10.